Welcome, everyone. We're getting started now for the Locker service. Excited to discuss the Locker service with you today while we overlook the beautiful view of the Grand Canyon to your right. My name is Mark Goldstein. I am a success specialist here at Salesforce. Essentially, I'm part of the customer success group. I come in and help customers adopt features on the Salesforce platform, ensure they're maximizing their return on their Salesforce investment. And one of the primary areas that I focus on has been Lightning and Lightning adoption, as well as helping customers with the technical challenges of Lightning component development, et cetera. As always, start with our favorite forward-looking statement, make any purchasing decision on what's currently available in the product. From an agenda perspective today, we're going to walk through a couple key features. First, want to kind of set the context of why the Locker service exists, kind of again, the challenge it's solving, what it does and how it works. So moving into that, just giving a really brief demo of showing you how it would work and the issues you would face with the Locker service. Then going to get into readiness and enablement. This is an area that has changed over the last year in terms of how we're rolling out Locker service. So I want to make sure everybody is understanding what the rollout is and how you can control the rollout in readiness. Going to talk about alternative isolation methods as we get into isolation and why it's needed, other methods of doing that outside of Locker service at a high level, and then going to save some time at the end for some Q&A. So we'll save the questions to the end. We have a mic here at the end to handle any Q&A. So just hold your questions, and we'll make sure we get to them as we move through. All right. So to start off with, I want to kind of set the context of why we built the Locker service, what the purpose is, and why we're all here to discuss it. A browser isn't built for multi-tenancy, right? As we start to build an any component framework, I have multiple components. The way a browser works by default is I have one JavaScript global object. I have one document object model. From JavaScript, I have access to that entire, everything in the DOM, everything in that window. So ultimately, in a component framework, that would allow components to cross and affect the behavior of other components and potentially bring in some security risk. In addition, the style sheet is global, so you also could be overriding style, and there's, again, a lot of inherent risk with that. So that the impact you have with that one unified DOM and browser is that components can inject JavaScript without restriction. So again, that could be a very big security risk there. There's ability to read from other components. We'll show that in the demo, how that works with and without Locker service. You'd be able to call both undocumented and private APIs that exist in the Aura framework or available on the API. And as well as there'd be access to other events, URLs, cookies, maybe things you don't really want other developers, other components to have access to. When we think about this, really the primary risk that we're trying to avoid is cross-site scripting. So cross-site scripting is one of the most common threat to web browsers in general in terms of from the JavaScript side. And again, this is really what we are fighting. So what happens with a cross-site scripting attack is, our little Red Hat perpetrator here, discovers a vulnerability, can inject that code into another component, to another area of the site, run that malicious code, so then as users come through, you would be able to essentially, grab their cookies, grab a lot of potentially personally identifiable information, et cetera, by using this type of cross-site scripting attack. So as we talk through isolation and the need for this, this ultimately is what we're trying to prevent and providing this level of security built in to the framework. So the Locker service itself, it brings essentially multi-tenancy to the browser that we wouldn't have otherwise by what we call sandboxing the code or isolating each component to essentially its own virtual DOM, right? So instead of having now one unified DOM like we would have without Locker service, now each component would only have access to other items within its own namespace. It is, again, is a virtual iframe, but yet it doesn't have the drawbacks that a traditional iframe might have in terms of it is still within the same browser and DOM. So the benefits here is, without this, as a developer, I have to worry about, how do I control, how do I prevent cross-site scripting? And it really leaves a lot to the developer to ensure they're following best practices, to ensure that they're not, again, leaving their code more vulnerable to these types of attacks. This prevents cross-site scripting, DOM scraping, and other similar types of risks. It does that essentially through proxying the JavaScript through protected JavaScript proxies automatically, so that you only have access to the namespace that you work. Again, mitigating the impact of developer mistakes and providing security across the entire platform so that we can avoid a lot of those security challenges. And starting to think about this in terms of an example or how this might work is this example here. We have essentially a couple different namespaces, right? Where you can think of components you might bring in from the App Exchange, components that you might be out of the box from Salesforce, like a UI button. And here I have the weather component. I have a subcomponent in there, this map component. Both of these are in the NS1 namespace. This one at the bottom is in a separate namespace. So again, without the locker service, we would have essentially the ability for everything to talk to everything. So in this picture here, the DOM, the body, the individual input button, the weather one, the map, the finance, there would be no restrictions if I could access that from the JavaScript directly, which again provides a lot of those security risks we talked about. With the locker service enabled, we provide, again, that virtualized DOM experience where now each namespace is automatically kept in its own space where that I can only talk to my own namespace. So any Salesforce authored components, anything that comes out of the box with Salesforce, will have access across all components. So that is the one exception with any Salesforce component that will have full access. Access will be granted if the component is in the same namespace. So if you're developing a lot of components within your org, you would have access to talk to those other components. Access is denied if the component is in a different namespace. So again, we think about this. I can no longer talk from the NS1 weather app down to the NS2 finance apps that we saw in the first. And then we also, in addition to that, use strict and CSP or content security policy to enforce additional restrictions on cross-site scripting. So strict mode helps out in a couple of ways. It essentially catches a lot of the common mistakes and throws exceptions. It won't allow you to essentially do unsafe actions, such as gaining access to global objects or hidden APIs, et cetera. So this, when the locker service is enabled, will be enforced across all the components using the locker service. So let me show kind of a quick demo of what this looks like, and I'll first show you what a component looks like with and without the locker service and the types of errors you might hit, and then I'll show you kind of the code and how we go about enabling that. All right. All right, so I have two components here. I have this one here where the locker service is disabled, and I'll show you the code for this in a minute, but ultimately what I'm trying to do is I have this right here as a component, this top line with the locker service disabled. This right here is a component where the locker service is enabled. And then I have this, which is in a standard component, so essentially a component that's in a different namespace than the ones I created. What I'm just trying to do in this example is access the inner HTML or get this text and display it. So with locker service, as I described earlier, I won't have access to do so, but without locker service, I would. So in the first example, I click this click me. It's giving me the HTML, essentially, of this section. I have full access to render that HTML, and you kind of see the text in there. I just from the one DOM have full access. My second component here, I have the locker service enabled. It is the exact same code, but trying to just access the same element. When I click that now with locker service, I will immediately get an error, right? So now I get, it just just demonstrating, the type of problem and the type of issue I'll have with the locker service and trying to essentially protect me as a developer from doing things I probably don't want to be doing. All right, let me show you a little bit of the code from that demo that I just... All right, so all I had in that button, as I said, is I had a very simple button that I was clicking that was running an access component. That access component method was really just looking for text on the page that had this style sheet and then was returning the inner HTML. So I was just, again, without any kind of isolation, I'd have full access to grab anything else on the page and do that. So that's the code was doing. Pretty basic example, but just showing how I was just trying to read the inner HTML of that particular record. So that's what we just saw. And then the next, I think, logical question we come into is, well, why did one work and why did one not work, and how did I control that as a developer and enabling it in my org? So from a readiness and an enablement perspective, this has changed, as I said, in terms of how we're rolling it out. It was originally being rolled out as a critical update, kind of across the board, and we changed gears with this because with overwhelming feedback, we had developers and orgs that really weren't ready for the data for the locker service and wanted to give the customers more control of how and when it will be enabled. So with that being said, the way we're rolling it out is via API version. So when I create a Lightning component, I create it with an API version. With the summer 17 release, our current release, we're now on API version 40. Essentially, any component developed on API version 40 or higher will automatically enforce the locker service. Any component below 40, so 39 or lower, will ignore the locker service. So this gives you the control of, yes, it definitely makes sense from a security perspective to move your components to version 40 once they're tested and ready, but at the same time, control of when you're ready to make sure they function properly. So by, again, updating the API version, when I'm using the dev console, just gave a screenshot of this, you simply go into the bundle version settings, and then I have the API version that can be set and changed on the component itself. So by doing that, that will set it up. We've also decided to separate two things, which is the locker service, which is really about isolation between objects, which I saw, and also content security policy. Content security policy, it disables, again, unsafe browser features, whitelist libraries, and it is available in most modern browsers, which I'll talk through. We determined, though, to separate the way that's enabled. So again, locker service, just where I have to talk across. For CSP, or content security policy, this is being rolled out through critical updates. So as of right now, content security policy is not enforced anywhere outside of sandboxes. So I can enable, it is available in sandboxes. With Winter 17, we will be enabling it via a critical update across all orgs. However, you have the ability to turn it off if you needed to. And then as of winter, following winter, it will be fully enforced where it cannot be turned off. The one exception to note was Internet Explorer 11. As many of you are probably aware, we originally were planning on preventing or stopping support for IE 11 as of this December. We've since decided to extend that to 2020. But the whole reason why we were initially not going to support it was because it does not support content security policy. So if you're using IE 11, regardless of your settings on content security policy, they will just be ignored from an IE 11 perspective. So we certainly, again, recommend the modern browsers that do support this, but that really was the reason that initially IE 11 was in that state. So some of the best practices and things to think about when you develop code is you want to make sure you're making your code ready for modern JavaScript, right? So you want to use strict mode is going to be enforced without locker service. The developer would have to essentially say to use strict. With locker service, it's going to be always turned on. No unsafe eval allowed. Modern libraries, I'll get to them on the next slide in terms of what modern libraries are supported within the Locker service, and then you want to test your code with Locker service during development. So both from obviously a straight regression, I'm also going to get into the tooling that can be used to help scan your code and understand if it is Locker service compliant or not. Again, even though we can bring the API version down and ignore the Locker service essentially, we do highly recommend that you work to get your components up to version 40 so that you don't have those security risks. And from a browser support, all the modern browsers, Microsoft Edge, Safari, Firefox, and Chrome, do support CSP. The IE11 issue I just mentioned is what prevents us from supporting it on IE11. This is a list of the current third-party libraries that are supported in the Locker service. So, we are working to bring on more and more libraries and capabilities right within the Locker service. But as of, at least a couple of weeks ago, this is our most current list. The green, obviously fully functional. Some of the yellows there, we're working to bring full functionality. But, a lot of the common frameworks and libraries you work with are supported now within the Locker service. From as I mentioned, another key part here is what tools can I use to help me and understand what of my components today are going to be Locker service compliant and which ones are not. We provide a code scanner or linter tool, right? This linter tool will scan through your components and actually bring you back all the potential Locker service risks that you have. So this is it runs as part of the Heroku tool belt. Again, you can install the Salesforce Lightning CLI, which is the name of the tool. And then when you run the CLI in the command line, it will go through your code, lint it, and let you know of the potential issues that you have so that you can remediate them in your org. We also are going to be providing a Locker service playground. Essentially, going to be looking to provide an area where you can test your code quickly, where you can evaluate performance of how it's performing with the Locker service on and off. So this, we hope to be bringing very soon. Again, and then to test on different browsers so that you can go to different browsers and see exactly how your specific code and component would work in those various environments. So the Locker service is the Salesforce way of preventing the iframe, right? So that's what it does. It virtualizes it. The other way to isolate components into their own DOM is through an iframe, right? So we could create iframes, and in that case, they're already going to be contained. So we do have the ability, if we don't want to use Locker service, to also consider iframe solutions to do that. Our native method of handling this is what we're calling Lightning Container Components. These are currently in dev preview, which means they're available in developer edition orgs, but not yet available in production. Essentially, I just use this Lightning container tag, my ID, and I include my resource, which could be an Angular app, a third-party type of app that I want to embed within an iframe. So I can also consider these going forward as another method of isolation. Again, it is implemented as an iframe in terms of how it's rendered. It will support any third-party library. So unlike Locker service, which we have to make sure that they're compliant before they'll safely run within the Locker service, if I'm iframing, I can run absolutely any framework within the component. And these are great for kind of mini apps that are maybe more standalone or run within a component. So just to kind of give a high-level overview of the difference between the two options, and this is generally as a developer what you're kind of thinking about as you develop secure component frameworks is, what are the trade-offs? Locker service is not an iframe. It is virtualized. Lightning container component will always be an iframe. Components laid in the same DOM, yes, with Locker service, even though, as we showed, you won't actually have access across different namespaces. But with an iframe, it'll actually load a separate DOM. The third-party libraries is really the main reason, or one of the main reasons you would consider Lightning container components. But for a more cohesive UI, that can get a little bit more complex with an iframe. So as you think about If I need to have interaction between, it's a little more complex. With Locker Service, I can use events and native Lightning component events. Whereas if I'm using a Lightning container component or an iframe, I'd have to use the post message to communicate across the different DOMs. From a performance perspective, the Locker Service is lighter. Everything's loaded in the same DOM. Obviously, with a Lightning container component, it can become heavier, especially if you have multiple iframes. There can be overhead of launching that iframe. So at the end of the day, both of these technologies and methods are ways of ensuring that you have secure code, that using the container framework, that, again, there's not vulnerabilities of third parties or other JavaScript injections happening, and really two different options as a developer to implement it based on your specific use case. So I know we have some time left. I want to just open up, if anyone has any questions, to just please come up to the mic here just so everyone can hear, and I'll do my best to answer them.
Hi. Lightning in Visualforce and Lightning out in general. Is Locker Service enforced, not enforced, depend on API? Yeah, that is an iframe technology.
Right. So it's essentially if you had two components available on the same Visualforce page, for example, it would interact the same way in terms of I would not. It depends, but ultimately the API version is what's going to turn on that service. So if I had two different components and different namespaces in the same Visualforce page, I would not have access in between.
Okay.
Yep.
So, with Locker Service enabled, is it expected a component to have access to the DOM of any of its component facets, such as vBody or any other components you put inside an attribute?
Yeah, you will have availability to within the same namespace.
So it's the same namespace. Like if I downloaded third-party components and put that in my vBody, I would not have access to.
Correct.
Okay.
Yeah, and then so if you need it, and then that's when you have to start using kind of events for communication across components, or if Locker Service is enabled, I would not have it across. Same rule.
Okay. Thank you.
Yep.
Hi. Hello. What if you want your Lightning component to talk to the outside world, or vice versa? This is the context of CTI. We are a CTI provider. We integrate with Salesforce, and our softphone is in the CTI iframe. We would like our component to react to events there, and if we enable Lightning Locker Service, we cannot get through.
Yeah. So. I don't, JF, have you faced that? If you want to help out, if you can maybe, JF's on the product team too, will help me up with some questions.
Can you hear me? Yeah.
Yeah.
So there are different ways to get there. It depends what you're trying to do. You can try to go through a controller method on the server, an Apex controller. So that could serve some use case if you need authentication and you don't want to provide those keys to the client. Or you can use a utility iframe that has less security restrictions and can allow you to escape the main page. So the utility iframe gets the XHR out, gets your content back, and then you pass it back to the main iframe using post message. There are a few libraries you can find. If you search on GitHub, you're going to find a few implementations. We have one. Other developers have created Accent alternative for XHR. You can also use Lightning components, so you can look around and you'll find a way to get there through iframe.
Thanks.
In your demo, if all of the Lightning components you showed are they all in the same namespace, and is that then why were they not able to access each other?
I'll show that again just so to make sure that's more clear. In my demo, this component here is a standard Salesforce component. So I just brought in the rich text component of the app builder and just put that here. I'd be able to talk back and forth between these two because these are both custom components in my namespace. But again, I didn't have access to here. So this one that's in version 39, again, had the access and 40 would not.
And so therefore, anything I develop by default is in its own namespace, separate from the Salesforce standard components namespace?
Yeah, that's correct. So when I just pop up the developer console, so you see that when you see when you bring in components, they will have the namespace up front, which is going to be the C colon for anything you develop, but there could be others available, and anything you bring in from the App Exchange would have a different namespace.
So I have a question. So basically, we said that within the same namespace, we can do all the access of the DOM and things like that, right?
Yep.
But even the same namespace, if we are using some of the UI libraries, and then when we try to tweak the DOM, maybe adding some more layers, doing some modifications, that all breaks as soon as Locker service is enabled. Let's take example of any of the jQuery UI library or anything else, right? It start breaking as soon as you enable that. So will gonna work right from the summer 17?
Let me just pop up this.
It might depend on which version of the
Yeah.
jQuery UI. We have a bug that just appeared because of jQuery 2.2.4,
Yes.
and we're fixing now. But if you go back to 2.2.2, where our tests are currently running, it's jQuery UI on top of jQuery 2.2.2 function. Works perfectly. And if it doesn't work, we'll fix it. We might have to juggle a little bit on the different versions of jQuery.
Okay.
And I don't know if everyone heard, but what he basically said is it depends on the version. So if you're using a version of jQuery that wasn't officially supported, you would have issues. As of now, 2.2.2 is the supported version.
And is there a live page where we can, get this all list somewhere being?
I don't know if it's available yet, but it will be. It's pretty new, so we will, I'm sure, get it up to the developer for site, but I'm not sure if it's there yet.
Okay.
Yeah. Right.
Thanks.
Yep.
Yeah.
So my question is the Lightning container component just the Lightning version of iframe in the Visual Force?
Yeah, you can still do a straight iframe, right? What the Lightning container component does is essentially do all the lifting for you. I just put in what the resource is. It configures it as an iframe and renders an iframe automatically, so it provides advantages. As I said, that is not yet available for, it's only in DevOrgs, but it does make the implementation for developers easier.
Okay, I see. When do you plan to put it in production?
When will it be in production?
Yeah.
Do you know, is it winter? Yeah. We're expecting winter release for it to be available,
I see.
which is October, November timeframe of this year.
I see. Oh,
Yeah. Yep. Yeah.
But does that mean that we have less control also? I see.
Yeah, that's a tough one to answer.
So got it. The other question is, what's the content security policy really about?
So the content security policy is, it's really about whitelisting unsafe, or whitelisting any behavior that would be unsafe. It wants to prevent unsafe browser behavior. It's going to prevent things like whitelisting libraries that have access to whitelisting potentially other functionality built into the API to prevent JavaScript from talking across.
CSP is a big thing. It's an umbrella of features that you can enable in the browser. But the ones we're looking at, the more specific ones that we do, is we disable unsafe inline and unsafe eval in the main window. So you don't have access to script tags. You cannot inject, say, HTML that could have a little bit of JavaScript in it. That will be prevented. You cannot do on-click equal to JavaScript something. So all of those things which are usually issues. And even if we were to support that directly with Logger Service, it's really, really hard to do. We disable it. And those are probably old techniques that, like, and on click, we can do it a much more elegant way today with a query selector. So we push people to these safer techniques. But those are the two ones you need to look at: unsafe eval and unsafe inline.
Yep. I think you have one more question. Go.
So we are using this approach of embedding the Lightning app in a Visualforce page in order to show a full-blown page on the quick actions, basically. So what happens when we are using this approach is we are unable to use the standard events like navigate to URL or navigate to a component. So we are ending up using the window object of browser. So do you think there is another alternative to use the window object with Lightning, the Locker service enabled?
So you're talking about redirecting from Lightning out, essentially, right? Is
Yes.
the question. I'm not sure if, so you potentially could use like an sforce.1 redirect, I think, in that.
Yeah, we are using that.
And you're having issues with that?
We are using sforce.1, but we are not facing any issues. But say, for example, we are unable to detect the sforce object based on the browser, or then we end up using the window object. So that's like an exception handling that we have. But there are scenarios where we might end up using the window object. So.
Mm-hmm. Yeah.
Okay.
So, yep.
Yep.
Excellent. So, yeah, thanks, everyone. We are out of time. We'll be hanging out on the side if there's any additional questions, but thank you very much for attending. Thank you.